Hi everyone. My name is Joe Greendyk, and I'm a freshwater mussel researcher working with Cedar Creek Institute and Grand Valley State University on a mussel community survey of the Thornapple River in southwest Michigan. I wanted to take a moment to put together this quick video giving a general overview on mussels since it's a topic few people are closely familiar with. Before we get started, I want to first shout out my fellow researchers on this project, John Leja and Professor Eric Snyder. You'll see them make a few star appearances in the sampling footage that's scattered throughout this video. So, today we're going to talk a little bit about freshwater mussels in Michigan. For starters, we'll give a brief outline of a few background concepts and mention which groups or types of mussels we have here in the state. We'll discuss a few key terms and features, and then we'll move into the unique life cycle of mussels. Following this, we'll close out with a brief focus on what roles they play, meaning both historical uses by people and ecosystem functions, and why they matter. I've pulled from a variety of sources to compile this video, and I'll list them all at the very end if you want to do a deeper dive. Diving right in, freshwater mussels are benthic, sessile filter feeders that occupy streams, rivers, and lakes all across the globe. So essentially, they sit on the bottom of these water bodies in the sediment. They don't move very much once they've established themselves, except for a few minor adjustments, and they grab bits of plankton and organic material out of the water column. Here in Michigan, we have four families of mussels: Spheridae, also called the fingernail clams; Sirenidae, the invasive Asian clams; Dreissenidae, the invasive zebra and quagga mussels; and Unionidae. Unionidae is the key family of interest, as this is the group that contains nearly all of our native mussels. Unless specifically stated otherwise, most of the information in this video will be focused on Unionidae. While there are nearly 300 species of unionids in the United States, only 43 of those occur in Michigan. One key thing to note here is that of those 43 species, 31 are listed as either special concern, threatened, or endangered on either the state or federal level, or both. So they're pretty clearly an imperiled group, which we'll get into more later. Alright, I next want to very quickly mention a few key anatomical features of freshwater mussels. I've added a few diagrams here, and I know it's a little overwhelming to see all these terms at once, so I'm just going to highlight the key parts step by step. Focusing first on the internal parts seen on the left. Obviously, there are the essential parts like gills for breathing, muscles, a digestive tract, and so on. On the right, the two siphons are used for sucking in and pushing out water for feeding and breathing, and these are often what we researchers use to visually pick them out from the sediment. These siphons can be seen pretty well in this quick video clip showing some three-ridge mussels hanging out in about 8 feet of water in the Thornapple River. I think this video also just gives a great general idea of what a bed of mussels looks like on the bottom of the river. Moving on, the beak, also sometimes called the umbo, can be seen on top. This is essentially the hinge point that connects the two shells of a mussel. One important thing to note is that this is one of the key defining features that helps us distinguish between species, which we do based on its height and structure. Beak structure can vary widely between species. For example, the mussels seen here on the left have 3 to 5 large, well-defined ridges on their beaks, while the mussel on the right has no notable beak structure. Switching back to our diagrams, we can also use two types of teeth for IDing empty shells, both lateral and cardinal, which are seen just below the beak. Lastly, the foot is a large muscle that is used for digging and positioning in the sediment. Moving on to the outside of the shell, there are a number of features we can also use to help ID mussels, such as pustules, ridges, and the presence of a sulcus, which is this shallow U-shaped groove. The overall important takeaway here is orientation terminology. The anterior end is the smaller, typically more rounded end that is embedded into the sediment. The top portion that has the beak is called the dorsal edge, and the bottom side, opposite of the dorsal edge, is called the ventral edge. Lastly, shown here on the left is the posterior end, opposite the anterior end. This posterior side is another useful ID tool, as it can take on a variety of shapes, sizes, and features depending on species, sex, and inherent variation, seen here in a picture of this fluted shell, Wabash pigtoe, and male and female plain pocketbook. This next short clip shows a mussel's siphons briefly as well, But this is also a great example of how, because mussels sit on the bottom and don't move very much, many times the exposed parts of the shell becomes covered in silt, algae, and in this case zebra mussels, which can make finding and identifying them pretty tricky at times. Next, we'll move on to the pretty fascinating life cycle of a unionid mussel. The process starts with male mussels simply releasing their sperm into the water column. This sperm is then picked up by a female mussel as she sucks in water through her siphons, where it is used to fertilize her eggs. These fertilized eggs turn into little larval mussels called glochidia. Glochidia are released into the water column, where they must attach to the gills of fish to survive. They parasitically feed off the gills for a short period of time before they undergo metamorphosis into a juvenile mussel, at which point they drop to the sediment and begin filter feeding and growing into adults. This host fish requirement is special for a number of reasons. For one, each species has its own set group of fish that it can use as a host, with some mussel species requiring one or two specific fish species, while others can use a wide variety of fish species. This specialization has led to some species of mussels developing a lure out of modified mantle tissue that they can use to attract target fish. A fish attacking the lure triggers the release of glaucidia, giving them better odds of attaching to a host fish. Additionally, host fish carry the glaucidia wherever they travel, meaning even though the adult mussels don't move, the species itself can still expand its range and travel throughout a water body by traveling with fish. It's pretty neat knowing some of nature's most avid anglers are eyeless mussels hanging out on the bottom of water bodies all across the state and nation. Alright, so there's a couple additional things I want to touch on before we wrap this up. The first is what factors either contributed or are contributing to the harm of mussel communities. As I mentioned, unionid mussels are one of the most imperiled groups in the nation, with about a third of the nation's species being federally listed and nearly 3/4 of the state species being either state or federally listed. One of the historical contributors to this decline was human use, as mussels were heavily harvested in the early to mid-20th century for use in the button industry. In addition to this, invasive mussels, such as the previously mentioned zebra and quagga mussels, as well as Asian clams, can overpopulate and outcompete our native mussels. In this footage, you can clearly see a large covering of zebra mussels that is dominating the riverbed in the lower Thornapple River. This zebra mussel infestation was just below a large dam, which leads me to the last key contributor. Human alterations of water bodies through pollution, runoff, riparian zone development, and dams can disrupt mussel food supplies, decrease water quality, destroy mussel habitat through processes such as sedimentation, and inhibit the movement of required fish species. Clearly, there are a number of adverse conditions these mussels are facing. So, one of the big questions we get as mussel researchers after mentioning how imperiled they are is, well, what do they do, or why do they matter? For one, mussels are important tools for scientists. Because they can't move to escape poor water conditions, researchers can analyze mussel communities to get a better picture of the overall health of a body of water, like you're seeing in the current video clips. Additionally, they're considered ecosystem engineers, as they can modify or stabilize benthic sediments and alter water conditions through filter feeding. Lastly, they're a vital food source for many organisms, including birds, fish, like the freshwater drum, and mammals, such as raccoons, muskrat, and mink. You can sometimes find discarded piles of mussel shells from these animals, called middens, lining the shores of some water bodies. Alright, that's all I've got for now. I've left a couple of links here to sources used for this video that provide a little more detailed information anyone might be interested in. If you are interested in getting involved, feel free to reach out to your local watershed organization, nature centers, or even university professors to see if they have any ongoing projects or surveys. Finding volunteer surveys and workshop opportunities can be as simple as following these local organizations on social media or even signing up for an email list. At the very least, next time you're around a body of water, keep your eyes peeled for spent shells along the shore, and if you're lucky, you may even stumble across a live mussel hanging out in the shallows. Hopefully this has been a helpful video and inspires you all to dive deep into the world of freshwater mussels. And I'm leaving you with just this last short clip of an interesting malformed mussel that I stumbled across in the Thornapple, which also gives a great example of the large foot that mussels have. Thanks for watching.